So welcome again, and today we shall discuss about the classification algorithms in machine learning. So I'll walk you through the basic introduction of what are classification algorithms. So the meaning is like these algorithms are used to solve supervised machine learning problems. So supervised machine learning we dealt in the earlier episode was that we are working with labeled data set and the output is known. So to solve such kind of problem, to map this input to the output, we are using classification algorithms. This classifies data into respective classes. Simply, the name suggests that it is classifying. Now, famous example that we've done many a times, I have also discussed it. It is iris dataset, which is a multi-label classification problem. Here you have to classify the data, or you can say the output object into the species of iris, that is setosa, versicolor, or virginica. So this is what the classification is. And another example is predicting heart disease. Another is detecting tumor, whether it is benign or malignant. And we have done it in machine learning projects. So you can go through that once more if you want to revise it. So this was we were applying classification algorithms there. So now let's walk you through the classification algorithms. So there are various algorithms which helps you to solve the such supervised machine learning problem, and they are like KNN, that is K nearest neighbor. You've got CART or decision tree. This is the classification and regression tree. It is suitable for both classification and regression problems. Then you've got support vector machines, naive Bayes, and logistic regression. So it is not like that classification algorithms and regression algorithms both are used for supervised machine learning problems. But right now we are dealing only with classification problems or classification algorithms. So now let's move on to the description of each algorithm in short. So, like KNN is K nearest neighbor. What happens here is that it uses a distance metric to calculate the nearest distance from the K most similar instances. And what happens here is that this metric, this distance metric could be any, but by default it is Euclidean distance, and it has got a formula also. So this calculates it with the help of this formula. I'm not going into formula calculations, but just to give you a basic brief introduction that this uses this distance metric to calculate the nearest distance of the neighbors. And these k nearest neighbors, or this k is being user defined. I can define it as 1, 3, 5, or 7. Generally it is odd in number, and the new example, whatever the new example we give, the distance is calculated based on the value of the k. Now let me walk you through a little more in depth so that you understand this thing with this figure. Now suppose this question mark is the new example to classify. What happens is that suppose I give k equals to 1, so this nearest this new example will be calculated the nearest distance from the class 1 and class 2. The class 1 is the square and class 2 is triangle. So if this new example is nearer to this class 1, then it will be classified as a square. Now if suppose I give k is 3, so that means its nearest distance, the nearest neighbors, that is the triangles, will be the shortest distance from this newly given input. So what happens is that this new input would be classified in class 2. So now this classification is really based on the number of k, or the value of k I specify, and based on that the new input will be classified into the respective class. So I can give it 5. So whatever the distance, the minimum distance from these neighbors, the new example would be classified in that class. The simple logic goes behind k nearest neighbor. It is effective, but it is also having its pros and cons, because you have to um, hit and try with various k values in this. So now we move on to our next algorithm, and that is naive Bayes. Naive Bayes works with probability of each class. So what it does, it calculates the probability of each class. It is called naive because this treats every input independently. The negative side is that mm, you cannot treat every input independently. It adds cost of computation, and also that in real life this is not the scenario because somehow or the other the inputs are related to each other. So naive Bayes is like it at times gives you good results, but it just depends on we have to hit and try them, and that is support vector machines. This is also used widely, and this at times gives a real good prediction. This support vector machines, what it does, it draws a line that best separates the two classes. What we want is to classify, so this is separating the two classes. Support vectors, now there's an important term here, support vectors. These are the data points or instances, I can say. They are the closest to the line that best separates the classes. So this will be clear with the help of this figure that what are support vectors. So you can see this star and this two circles. These are support vectors because they are very near to this support line. And this is what it is doing, support vector machine. This draws a line, this separates these two classes, class 1 and class 2. And these are the support vectors which just really help you to determine to which class the new instance would belong. Okay. So now we move on to another algorithm, classification algorithm, and that is logistic regression, mostly used. But it is regression and we are using it for classification. So here is a catch. The catch is that logistic regression works well with categorical data, and it is called regression because it uses the equation of line which linear regression uses, right? So it classifies the data into separate classes, and this figure would explain things with very clearly. What happens is there's a sigmoid function, a slight S curve, and what happens is that if you can see this threshold value, if our data or any instance it lies above this threshold value, then it would be classified in the above class. Otherwise, it will be classified in the lower class. So this is how it works. It just works on this threshold value, and it categorizes, it just classifies the data, the categorical data, which can be really separated into separate classes like 0 or 1, whether I have got these real numbers, or I am working with a label called survive not survive, whether you are yes or no. So this can fairly work well with these data sets. And now I come to the end of this video and this podcast episode, which is already there in FM, anchor.fm, and several other platforms, Spotify, Apple, iTunes, Google Podcasts. So go and please hear those, listen those, and there is much more variety and more episodes being uploaded there. This is just a selective version of it. And in the next, I'll be coming with regression algorithms. So stay tuned and thanks for listening.